Okay. Hi, everyone. Okay, so this is Miss Waringle. This is going to be your test review. And so on this test review, I'm just going to go over your guys' unit test that you saw on Edgenuity. Okay, so the first question that it has is, can I make this smaller? Nope. Okay. So it says Maria made a histogram to represent her jogging miles. The height of the bars in the histogram represents. And so what they're wanting you to do is to figure out what is the height of those bars going to represent. So if we're talking about the height, we're talking about the y-axis. So here it has it labeled for you. So the height of the bars represents the number of runs. Okay, so here Maria ran from 1 to 1.99 miles on two of her runs. So the height of the bar represents the number of runs. Okay, let's look at this next question. Let me move my face. Okay, so it says Sydney's teacher says she may have her report card percentage based on either the mean or the median and can drop one test score if she chooses. So her test scores are 94%, 84, 100, and 68%. Which measure of center should Sydney choose so she can have the highest percentage possible? So the very first thing you need to be able to figure out is that, do you know how to find the mean and median based on those numbers? Is it recording? Okay, so what I did down here on the bottom is we're gonna find the mean and the median of just those four numbers, okay? So the very first thing I did is I labeled mean and median so I'm able to organize my work. And then down here on the bottom, I went ahead and put the numbers in order from least to greatest so I could find the median because the median's a lot easier to find. So to find the median, you're going to mark them out. And I'm left with 84 and 94. So what you're going to do is you're going to add those two numbers and then divide by 2. So your middle number will be in the middle. So for the median, the median, when you add those two and then divide by 2, we got 89. Okay. And then for the mean, remember to find the mean, you have to add all your numbers. So whenever you add all your numbers, I got 364. And then you have to divide by how many numbers you've added. So we've added 4 numbers. So you're going to do 364 divided by 4, and we get 86.5. Okay. So now we have to compare that mean and median to the numbers without, because she said the teacher could drop one test score. So if I were to look at her scores, I would drop 68 because that was the lowest Sydney made. So you're going to do the same thing. You're going to put your numbers in order. Okay, so down here on the bottom, I did the same thing. I organized it. So I have my mean and median labeled. And down here on the bottom, I dropped that lowest score. So her lowest score was 68. So the first thing I want to do is find out the median. Well, 94 is the median. So I'm going to write that here. Then I want to find the mean. So remember, your mean is whenever you add all your numbers and then divide by how many numbers you added. So whenever I added all my numbers, I got 278. And then you're going to divide by 3. And I got 92. Well, my equal sign and then 92. Okay. So back to the question, it says, which measure of center should Sydney choose so she can have the highest percentage possible? So looking at all of our numbers, so this is a 5 actually. Okay. So looking at all our numbers, and I'll do this in green, we have 86.5, 89, 94, and 92. So we have to figure out which number would we use for Sydney's grade because she wants the highest grade. So the highest grade out of all 4 of these is actually 94. Okay, so Sydney would want to drop her lowest score and use the median for her highest percentage. Okay, well, I hope that one helped. That was a long one. All right, next one. It says, here, let me move my head. Okay, it says the stem and leaf plot shows the number of calories in one serving for 12 different snack foods. How many snacks have 100 or more calories in one serving? Oops, things are flying. Okay, so if I were to look at your stem and leaf plot, so it has a key down here on the bottom. You have 8 and then 0, and it has that line there. That means 80. So what you're going to do is you're going to look at your stem and leaf plot. Well, 100 or more. So I'm looking at everything that's here circled in this yellow box. So we have 1, 2, 3, 4, 5, 6, 7, 8. So we have a total of 8 snacks that are 100 or more calories based on the stem and leaf plot. Okay, let's look at this next one. All right, it says use the data on the dot plot to answer the question. How many people read for more than 3 hours last week? So what we need to do is we need to remember that one of these dots is equal to one person. So here's my person. Okay, and back to the question. So we know one dot is one person. So how many people read for more than 3 hours last week? Well, is 3 greater than 3? No, so I'm not looking here. I'm going to be looking at everything else. And so what I want you to do is I want you to pause the video and see if you could figure out how many people read more than 3 hours last week. Okay, so you should have gotten 14. Oh, that's kind of hard to see. So you should have got 14 as your answer because there are 14 dots on 4, 5, and 6 together. All right. This next one, it says Nora wants to find her average grade in science class. She has earned a score of 85% on 2 tests. Okay. So what I look at is on here, since they wrote out the number 2, I'm thinking they're trying to trick me. So I'm going to go ahead and record my information here. So 85, and I'm going to write that twice because she made an 85 on 2 tests. Okay. And then she made a 92 on 3 tests. And I'm going to do the same thing. And then finally, she made a 94 on her most recent test. So that's just 1. And I'm going to underline 3 because they're trying to trick you there too. Now it's basically saying, what is Nora's mean or average test score? So they're saying that mean and average are the same thing. So what you would do is you're going to add all of these numbers up and then divide by how many numbers you've added. So I want you to pause the video and see if you can figure it out yourself. And then I'll come back and check it. Okay, so after I added all those numbers up, I got 540. And then we had to divide by 1, 2, 3, 4, 5, 6. And so 540 divided by 6, we get 90. So her average test score is 90%. Okay, let's look at our next question. Okay, so it says consider the 2 data sets below. So they're giving you a lot of information here. It says which of the following statements is true. So we're just going to go through the answer choices and just double check to see which one is true. So we're going to look at it, and the first one it says the values are not in order. Well, if I look at it, they're in order, so it can't be that one. Okay, and then I'm going to look through it. It says the data sets have different values for their interquartile range. Okay, so now I have to find the interquartile range. So what we're going to do is I am going to take a little shortcut on here. So I'm going to find my median here. And how I'm going to do this is I'm going to figure out how many total numbers I have and divide that number in half. So let's count. 1, 2, 3, 4, 5, 6, 7, 8. So I have 8 numbers. And what you're going to do is you're going to divide that in half. So half of 8 is 4. So 1, 2, 3, 4. My median has to be right here. So remember, for interquartile range, you're just needing that median to split your data in half. Okay, so now I'm going to look over here and find my lower quartile. So my lower quartile is going to be between 25 and 35. So that's going to be the same number. And if I look over here, my upper quartile is in between 50 and 52. So that means my interquartile range has to be the same thing if the numbers here are the same. So our answer would be C. The data sets have the same values for their interquartile range. Okay, all right, this next one. It says, what is the median of this data, of the set of data? So the very first thing you want to do is put your numbers in order from least to greatest. Okay, so I went ahead and I put my numbers in order from least to greatest. And I want to double check to make sure I did not forget any of these numbers. So let's see if I have everything. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 total numbers. So that means I should have 10 numbers down here on the bottom. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Perfect. Okay, so now we're going to find our median. Remember, your median is your middle number. So if there's 10, that means half of 10 is 5. So 1, 2, 3, 4, 5. So my middle number should be between 52 and 54. Well, our median would be 53 because that's the number in between 52 and 54. All right, let's look at this next one. Okay, it's giving us a lot of information here. So let me move my face. It says Donald compared the hours students spent each day on social networks to the hours they spent on homework. His data is shown below. Which statements are true? So the first thing we want to do is we want to go ahead and look at our titles. So this one is talking about social networks. The other one is talking about homework. So now we're going to look through it and figure out which ones are true. Okay, so whenever I do this, I like to figure out the ones that I know already off the bat are true or which ones are wrong. So let's start from the bottom. It says students are more consistent in the time spent on homework than the time spent on social networks. So consistent means that they stay around the same time. Okay, so since they're staying around the same time and I look at it, they're more consistent with their homework because you have one large cluster there. So this could be true. Okay, then it says the average student spends more time on homework than on social networks. So whenever they talk about average, they want us to find the mean. So I'm going to pause real quick because I don't want to look at the mean right now. Then the next one, it says there is a greater variability in the hours spent on social networks. So remember, variability is range, and that's pretty easy to find. So let's look at social network. The smallest dot that they have over here is 0. So 0, and then subtract. And the largest one here is 3.5. So 3.5 minus 0 is just going to be 3.5. So we're going to write that there because that's our range. That's the variability. And now we're going to look over here for homework. Well, the same thing here. The smallest one is 0. But be careful because down here on the bottom is 4.5. And I didn't see that when I first looked at it. So I could go ahead and assume 4.5 minus 0 is just 4.5. And so that means that homework has a greater variability than social networks. There's a greater variability in hours spent on social networks. No. Okay, the mean number of hours spent on each activity are equal. So now we have to find the mean. All right, so I'm going to erase some of this work so I can show you how to find mean because we need mean to figure out these two questions. Okay, so remember, to find the mean, you're going to add up all your numbers and then divide by how many numbers you've added. So this one, it's going to be a little tricky. So each one of these dots represents one of those numbers. So we have 3 zeros, 1, 2, 3, 4, 5, 5 0.5s. So just make sure that you are aware of that. So what I did over here is I found out when I added all of these together, I did my side work. So I got 27 here and I divided it by 18 because there's 18 dots. And we got 1.5. Okay. And I'm doing the same thing over here for homework. Remember, each one of these dots represents those numbers down there on the bottom. So I have 1, 0, 1, 0.5, 1, 2, 3, 4 1.0s. So when I added all those together, I got 22.5. Let's see how many numbers that is. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So I'm going to divide 22.5 and I'm going to divide that by 18. And let's see what we get. And we get 1.25. So now we're going to use those numbers to see if we could figure out which one of these two statements are true. It says the mean number of hours spent on each activity are equal. Well, that's false because those two means are not the same. Then it says the average student spends more time on their homework than on social media. Homework was 1.25 and social networks was 1.5. So that's not true. Okay. All right, let's look at our next one. Ooh, there's a lot of questions. Okay, so it says 2 students were asked if they like to read. Is this a good example of a statistical question? Why or why not? So if I were just to ask 2 students, do they like to read? Their answer could either be yes or no. So this question is not a good question because I don't have a variety of answers. It's either they like to read or they don't like to read. Well, that was pretty easy. Okay, so this next one, it says Jace volunteers for their local library. The librarian wants to find out whether the patrons prefer paperbacks or paperback books or ebooks. Jace cannot decide which method to use for polling the patrons. So they have 2 different options. Option 1, it says poll every 5th patron. So a patron is just a person, okay, who enters the library on Paperback Lovers Day. Option 2 is poll every 3rd patron who enters the library on Technology Appreciation Day. What do we know about these options? Are they biased or unbiased? Well, these questions are pretty biased because if I ask somebody on Paperback Lovers Day, those people like paperback books. If I ask people on Technology Appreciation Day, well, those people would like ebooks because they like technology. So these 2 options are biased. Okay, next question. A data set has a median of 12, an upper quartile of 15, a lower quartile of 10, a minimum of 4, and a maximum of 20. Which statement is true of the box plot of this data set? Okay, first off, I would want to draw a box plot, and it doesn't have to be the most prettiest box plot. So what I'm going to do is, it says the median of 12. So I know this has to be 12. Okay, then it says an upper quartile of 15. So upper quartile, I know it's to the right of the median. So this would be 15. Then it says a lower quartile of 10, and that's going to be on the left side. So this would be 10, and I'm just sketching it out just so I have a visual of what this box plot looks like. And I know here that this makes a box. Okay, then it says a minimum of 4. So that's talking about the left whisker, and this is 4. And a maximum of 20. So it's talking about the right whisker, which is 20. And so granted, my picture might not be accurate, but now I have a better picture of what this box plot looks like. Okay, so let's go through it. It says the box will go from 10 to 12. Well, that's false because this box goes from 10 to 15. So that's false. Then it says a line dividing the box will be at 12. Well, there's the line dividing the box. So that is true. And since this one is just asking which one is true, we know that these other ones have to be false, but we're just going to double check. It says the left whisker will go from 4 to 15, while the left whisker only goes from 4 to 10. So that's false. And the last one, it says the right whisker will go from 12 to 20. And that's also false. So our answer is a line dividing the box will be at 12. All right, let's look at our next question for our review. It says, which data display shows the number of observations? Check all that apply. So remember, observations is how many times were they asked this survey to different people. So we need to circle or check all that apply, that you can find it. So if I look here, since the vertical boxes here on our bar graph go straight up to a number, I could look at this, which is a box, I mean not box plot, a bar graph. This one also, since it goes up to a specific number, this works, and this is a histogram. And there's something a little odd about this histogram. Remember, histograms, those bars are touching, okay? This next one, this one is called a dot plot or a line plot. And you can also figure out how many people were surveyed. And these last two, a box plot and this pie chart, you can't really figure out how many people were surveyed here. So a bar graph, a histogram, a line plot, or a dot plot, those are the three ones where you're able to figure out how many people were surveyed. All right, let's look on to the other question. It says, Grace claims, I don't like this question. Grace claims the interquartile range of a data set is never equal to its range. Which type of set can be used to prove or disprove her claim? So let me tell you why I don't like the wording on this question. It says a set of consisting of identical elements. Elements? We haven't heard about elements this entire lesson. So what I think is when they're talking about elements, they're talking about different numbers. So let's go ahead and look at it. A set consisting of identical elements will prove her claim. And instead of elements, I'm going to say numbers. Identical numbers will prove her claim. That is it's actually false. Okay. A set consisting of unequal elements will prove her claim. That's false also. So the answer here is a set consisting of identical elements will disprove her claim. So if everything was 0, you would have the same interquartile range and range. Okay. All right, let's look at this next one. It says the distance in miles a car travels over time in minutes is shown in the table. Kwame is not sure whether to use a line graph or a line plot to display the data. So we have to figure out what is the difference between a line graph and a line plot. So remember, I'm going to even underline it. A line plot is just a dot plot. It's a line with dots. Okay? A line graph, and I'll do this in a different color so you're able to see the difference. A line graph, it's a line with an X and a Y, and it shows dots in a trend. Shows like change over time. So which one would be better? Well, since this is a change over time, a line graph is actually going to be the best one. So I could go down here and mark off the ones that are talking about a line plot. Is it raining? Okay. Mark off the ones that are talking about a line plot and look at the line graph. So here it says the line graph because the numbers in the data table are equally spaced. No, that's not the reason why we choose line graphs. We choose line graphs because it shows like a change over time. So the line graph because it shows how the number of miles increase over the number of minutes. So since they're talking about over the number of minutes, over extended minute time, Okay, so this would be your answer here. And I think we're almost done. This is our last question. Okay, what is the median of this set of data? So remember, the very first thing is you want to put your numbers in order from least to greatest. And if I were to look at it, they put it in order from least to greatest. So now we have to figure out what is our middle number. And since this is an odd number, or an odd set of numbers, we know that 103 is our median. So I got these questions straight from your test review. So I hope that this helps. If not, just message me, and good luck on your unit test. I miss y'all.